So I'm going to talk about weather radar and why weather radar is a unique and good instrument for severe weather detection. Well, first of all, a weather radar can detect many different phenomena that are important in severe weather detection. So let's take an example of thunderstorms. So weather radar can detect the thunderstorm. It can measure the precipitation in the thunderstorm. It can measure the vertical structure of the storm, and it can also detect the winds inside the storm. The modern Doppler weather radars are able to also detect the winds. So you can make really good measurements regarding the structure of the storm. You can track its movement, so you can see where it's going and how wide it is and so on. And you can generate warnings based on that. The severe weather detection is, of course, important in many different applications in urban weather, for transportation optimization, and especially for airports. So for all these kind of applications, the capability to detect different phenomena is important. The modern weather radars can also detect not just rain, but also other hydrometeor types. And it can classify the hydrometeors. So you can identify, for example, hails inside the storm. So you can detect hailstorms that are obviously dangerous for many different users of the weather radar data. You can also detect non-meteorological targets such as birds. Sometimes also migrating birds are dangerous, so the weather radar can detect those as well. The modern weather radars can also measure the rainfall estimates in really accurate manner. So you can use the rainfall estimates in modern hydrological models, and then those models can generate, for example, flood warnings. So there's many different types of information that you receive from a weather radar, and that makes it really unique in severe weather monitoring. In addition to these different kinds of information that you get from the weather radar, you can also cover a large area with just one weather radar, and of course even larger area if you combine many weather radars to form a weather radar network. And the resolution of the weather radar data is accurate enough and good enough for many different applications. So in the image on this slide, in the middle, you can see a theoretical example of a weather radar network where we combine weather radars with different frequencies into one network. So typically, surveillance weather radar networks are built using, for example, C-band weather radars, but there is typically some gaps in between the coverage of these large weather radars that you can fill with smaller weather radars, typically X-band weather radars. And Vaisala has these both available in the offering. So for example, the requirement for the data in urban areas might be different from rural areas. So the resolution of the data, quality of the data needs to be better in such areas. And the coverage of a large C-band weather radar network can really well be complemented by adding X-band radars into such locations to improve the data. The weather radar data can also be used to provide a short-term nowcasting, so forecast for a couple of hours, typically say 2 hours forecast, and it's based on the latest measurements from the weather radar. Longer term forecasts typically require other type of information and forecasting models and data from soundings and other instruments as well. But for this kind of short-term forecasts, weather radar information alone can be used, and you can make a short-term forecast. And that's really good also, of course, for making warnings, alerts, and detecting different kinds of phenomena in severe weather monitoring. Then what Vaisala has to offer in the weather radar product area. We have different weather radar models for different purposes. And what is important when building a weather radar network? Of course, data availability is the key. So it doesn't matter how good your radar is if the radar is down when there's something dangerous happening. If thunderstorm is approaching and your radar is down, it doesn't help if you are not able to use it. So data availability is really a key. And that means that your instrument's reliability needs to be really good. And then the data quality as well. If your resolution is not good enough and the data quality overall is not good enough, that leads to poor detection rates and possibly also false alarms. So data quality is a key as well. So you need to have continuous data 24/7 without any interruptions, and the data quality needs to be good enough that you don't make false alarms and you are able to detect the phenomena that you are interested in. And what in Vaisala's weather radar systems makes them unique and improves these two things, quality and availability. We have implemented the radars using an architecture where we have placed the electronics of the radar behind the antenna. So this way we can build the radar to be really compact, and we can simplify many things in the radar. For example, the signal path from the antenna to the receiver and from the transmitter to the antenna is as short as it can be. That simplifies the signal path, shortens it, which means that the data quality is better. It improves the rainfall rate estimations and the range of the radar and capability to detect weak signals. It also makes the site requirements easier. Everything is predefined, everything in one package. So you just need to design the place for the radar, and you already know before the delivery what are the site requirements. There's also some components that you don't need in this kind of architecture that you would need in more traditional weather radar architecture, such as there's no rotary joints, RF rotary joints, there's no waveguide switch, there's no dehydrator, there's no site-specific waveguides at all. And these all, when you remove them from the systems, make the system more simple and more reliable. So, and also easier to use. So that comes from the architecture design that we have chosen. We've also chosen the transmitter technology in the radar to be solid state technology. That also means better reliability and better data quality. So there's built-in redundancy in the transmitters. So you can run the radar even if there's some transistor in the transmitter is failing. So there's built-in redundancy in these modules. We also implemented a continuous calibration system, so the radar is performing a runtime calibration. So it's continuously calibrating itself. So you don't need to take it down for calibration. That also improves the data availability. There's no consumable components, there's no service breaks, so the data is available continuously. There's no need to calibrate the radar, even if for example, the transmitted power is a little bit lower than it should be, because the system is able to take that into account in the runtime calibration. So overall, the Vaisala weather radar systems are built for reliable operation and to provide high quality data. That is, both of those are the most important factors when building a severe weather monitoring system.